All right, so on the back of the page, we see our first word problem. There's a bunch of other word problems. We're not going to do the other ones today. We're going to like maybe do a couple tomorrow and then a couple when we come back from break. We're going to spread those ones out, but this one we're going to do today. It says you sell wrapping paper as a charity fundraiser. And the idea here is you sell wrapping paper as a charity fundraiser every year. And you've been keeping data as to like how this works out from year to year. Because you know, you've got a math teacher who volunteers for your charity, and what else are they going to do except keep data? Says the equation P equals negative 6x squared plus 280x minus 1200 models the total profit P as a function of the price X per roll of paper. Because that math teacher volunteering in your club, they've wanted to keep the data because they want to make sure you make as much money as you can. And so they did like a regression and they came up with this formula. What is the smallest amount in dollars you can charge per roll of wrapping paper to make a profit of $1,500? So maybe your charity has like a target. They're trying to earn $1,500 for some specific purpose. So you're trying to make sure that that's how much money you're going to earn with your fundraiser. So where does that $1,500 need to go in our problem? Rachel, yeah, it goes in for P. So we're going to start by substituting $1,500 for P because we have a particular profit target. Now, with this, we are trying to figure out how we should price it. That's the X. So we're actually looking for solutions this time. We don't just want to know, is it possible to earn $1,500? We probably already know that it's possible based on what's happened in the past. We're just trying to figure out how do we zero in on the right price so that we sell the right amount of wrapping paper. Everybody good so far? Yeah? I want to use the quadratic formula. What do I need to do to this equation before I can use the quadratic formula? Will, what do I need to do? Yeah, I've got to subtract that 1,500 from each side so that it equals to 0. Now, I'm going to point out something that you may or may not notice when you're working by yourself. If you don't notice it, you can certainly still solve the problem and get the right answer. But what do you notice about 0, negative 6, 280, and 2,700? They're all divisible by 2, right? Those are all even numbers. So just like you should always reduce fractions, you should also always reduce equations if possible. It just makes your numbers a little bit smaller, makes it less likely that you're going to have an issue with arithmetic, okay? If you don't notice, you still get the right answer as long as you don't mess up your arithmetic. But when you notice, sometimes it makes a big difference in how hard it is to do the problem. This time doesn't help a ton, especially since we're going to use the calculator anyway, but it's good practice. So let's go ahead and reduce that fraction to 0 equals negative 3x squared plus 140x minus 1350. All right, I'm looking for the solutions with the quadratic formula. Now, these numbers are enormous. So although we're going to write our work on our paper, we're going to do it in the calculator, and I'm actually going to do it on the calculator on the screen because I want you to see how you can use the calculator efficiently when you have two answers. So let's first write down what our formula is. Remember, we're starting with x equals. Right? X equals the opposite of B. What's the opposite of B? In this problem. Negative 140, thank you. Plus or minus. Now, I'm actually not going to do the discriminant separately this time because we are going to put it into the calculator. So I'm going to do the square root of, I'm going to literally write it out. You already told me that opposite of B is negative 140. That means B is just 140, and that's supposed to be squared. Minus 4 times A. What's A right now? Negative 3 times C. Yep, negative 1,350 or 1,350. All right, all divided by 2 times, what was A again? Negative 3. Okay, so I'm going to pop my calculator up here. Oh, I got about 100 windows open. Let's see if I can get rid of some of them. Oh my goodness. I was working on a lot of stuff in my play period today. Oh, there's my calculator. All right, so I'm going to clear my calculator out. And in my calculator, I'm going to make use of the fact that I can make a nice handy-dandy fraction by doing alpha y equals and choosing number 1 to make the little fraction symbol. So I'm going to do that. Then I'm going to enter my fraction exactly the way I have it written on my paper, except there is no plus or minus. Okay? So first we're going to do the plus 1. All right? So type it in just like you see it. Make sure that if it's a negative number, you use the negative button. And if it's a minus sign, you use the minus sign because they are two different things according to your calculator. And as long as you're in like the current math type, it will keep extending your square root symbol over what you're writing unless you put parentheses to close it. So you won't have to. It'll just keep making it bigger and bigger. And then you can arrow down to get into the denominator. Okay, does everybody see how I entered it exactly the same as what's written on my paper? Then you can push enter and it'll give you your first value. Now, this is a price. So what would be a reasonable way to round this off, given that this is a price? Yep, so what would I write? Yep, $13.62 is my first approximation. All right, so that was the plus one. Now I'm going to go up. I'm going to use my up arrow until the formula I entered is highlighted, and I'm going to hit enter. Notice it retypes the whole thing. What's the only difference that I need? Katie? Yeah, I need to change that plus sign to a minus. So I'm going to use my arrow keys to get onto that plus sign, and I'm just going to overtype it with a minus. And when I hit enter, I'll get my answer. That way I'm not risking typing it in wrong the second time. And that's a lot quicker than retyping all of that. Will?
So this question's a little different, but...
Okay, so how are we going to round this one? What would we say? $33.05. All right. So first we're going to just answer the question given the rounding that we've done, then we'll talk about the complications. It says, what is the smallest amount in dollars that I can charge and make my profit? So what's the smallest amount out of those two? Okay, so for the level that they want us to analyze this problem, we would say we should charge $13.62. Okay, that's the level of analysis that the problem is aimed at. But Will brings up an important point that when we start rounding like that, we're now not at that optimization. The issue is we don't know for sure whether rounding down or rounding up would actually put us closer to where we want to be. Here's the reason. Think about the two possible scenarios. Notice this model claims we make our profit at either the lower amount or the upper amount. We have to think about psychologically what's happening, right? No matter what, this is very pricey wrapping paper, okay? Speaking realistically, very pricey wrapping paper, even at $13.62 versus $33.05, okay? It's pricey. But this is a fundraiser, right? It's for your kid's school. You're like, whatever, I'll just buy some wrapping paper. I'm really just donating money to the school. That's really what this is about. So my kid does one of these, and it's like stupidly expensive wrapping paper. That's just the way it is, okay? So we're not really considering whether we think this is the amount of money that people really want to spend on wrapping paper. But what it comes down to is, at the lower price, a lot of people are willing to buy it. So we sell a lot of product in order to make that profit. At the upper price, fewer people are willing to spend that amount of money, even as a donation to their child's school. So we're going to sell less wrapping paper, but because we're making such a big profit on each roll, we still end up making the same profit overall. So which is more advantageous comes down to, do you have a lot of wrapping paper in your closet that you'd really like to get rid of? Then sell it at the cheaper price because you'll move more product. If you've got a limited supply this year, sell it at the higher price because you don't have as much that you're trying to get rid of, and so you need to make more per roll. Does that make sense? So that's like the first extra layer of analysis we would think about. We were told what decision to make in the problem, okay? So we didn't have to do that, but that would be the other deciding factor. Now, Will is raising the issue of, okay, but if I round down, I'm not really making that much money. That's right. But this is a model anyway, so it's already an estimate. Does that make sense, right? Somebody was collecting some data, they came up with this model, it was already an estimate. So we already know that that doesn't guarantee the exact target. So this is just getting us in the ballpark. That's also a really weird price, right? And if you think about it, when you go to the store, unless it's like some weird sale going on, they don't usually price things like $13.62. So chances are we'd do $13.99. Like if we're being really realistic with marketing, we would probably either charge $13.50 or $13.99. Those would be, or maybe $13.75, like that would be a price that they sometimes do, but they don't usually do prices like $13.62. Does that make sense? So if we're trying to get overly realistic, we wouldn't do $13.62 anyway. Okay? And it's a ballpark figure anyway, so we're not worried about the fact that when we round, we're not quite on point with the estimate. Does that make sense? Yeah? All right.